Hello everyone! Today I'll talk about ciphers. You may have heard of ciphers and keys, but what are they? A cipher is a way of hiding secret messages so nobody but you and maybe a friend you told how to unlock the cipher could read the secret message. But if everyone knows the ciphers because they looked on the internet, how are they to be kept secret? To make it secret, we use a key, which can be a number or a letter. We move a letter by the number, i.e., if a letter was A and the key is 3, I will count 3 letters from A. So A is the base, so it's 0. Then there is B, which is 1 from A, 1 step from A, and C, 2 steps from A. You go 1, 2. And D is 3. So we get our answer. D is A with the key 3. But what about the letter? As I said before, a key could be a number or a letter. Now we will focus on something called Unicode. Unicode is a way of representing a letter with a number. For example, A is 97 in Unicode, but 97 is over 26. This situation is XOR. But instead of it being the secret message, it is the hidden one, encrypted version. So that means if I have hidden message secret message, the hidden message will be 97 minus 26, because 97 minus 26, because, there's a part of 96 inside the 26, or the part of the alphabet, and then the rest will go to all the emojis or the symbols and some other stuff. Some in Unicode are actually not available. I actually don't know why. You could search that on the internet if you like. Now we will focus on a cipher called Pigpen. The Pigpen cipher looks weird and like a cipher. At the very beginning you see it. But don't worry, everyone might feel like that. Even me. I felt like that the first time I saw Pigpen. There's a graph with dots, a cross, and a cross with dots. Each of those container-looking things hold letters. I'll give you a minute to pause the video and figure out what the Pigpen cipher is. Once you have a few ideas, try and decode the secret message. These exclamation marks mean nothing, so don't worry about them. Okay. Now I will tell you what the Pigpen cipher is. Pigpen cipher, of course, it's a cipher, but how does it work? Well, firstly, in the graphs you could see shapes. For example, here B looks like that. E is a box. N is a box, but with a dot. Z is like that. So now let's decode this secret message using the shapes in which these letters are contained. So first one, we have this. What does this look like? It has to be G, because that also looks like this. A 7 maybe. a G. So now you know how the Pigpen cipher works. You could pause the video again and decipher the code. Great. Now I will show you the answer. Sorry, that's not what I've written. I tried to trick you. The real one is, if you look at here, it's a U. So the real one this time is, guessed it. Remember, these explanation marks mean nothing. You just copy them down. Okay, good work. Now you guys know what the Pigpen cipher is and how it works. You could teach your friends Pigpen cipher and send little messages to them any day, and other students may not know what Pigpen cipher is. So nobody will know what you're writing. Now we'll look at Sumerian counting. But why are we looking at counting? I thought this was a cipher class. Well, we are looking at Sumerian counting because it's going to relate to the next few slides, and you also may learn something from it. Now we have a hand. Why hand? Someone wants to ask a question? No. Sumerians use their hands to count. Well, I think we already know how to use our hands to count. 1 finger up, the index is 1. 2, like a rabbit, is 2. 3 is 3. 4 fingers up is 4. 4 hand up is 5. No, Sumerian counting does not work like that. Sumerian counting works something quite differently. I actually picked this picture for a reason because you could see its knuckles. And you would see how useful these knuckles could be at the end. The thumb, you could ignore that thumb for now. It's also called the pointer because it points at the finger. Now, index 1 is 1, then 2. At each knuckle, the pointer is supposed to point at where the number is. 3, and then if we draw all the knuckles to make it clearer, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now this may answer your most curious questions of all time. Why do we have to sell eggs in 2 rows and 12 on each row? That's for the Sumerian counting because there are 12 numbers on the hand, which you may think they're only 5, but they're 12. And maybe you could go down here and say here, this is 13. So you see, it's not only 5 numbers on the hand. It could be way more than that. 5 is like only in the middle. And what about 60 minutes in 1 hour or 60 seconds in a minute? Well, if you times 12 by 5, I could do the working out here. 0, 5 times 1 is 60. There's 60. But why is 60 that special? I mean, we don't have 5 hands or 5 body parts with knuckles. Well, 60 is very, very special to the Sumerians because it has a lot of factors. If you were a Sumerian farmer, you will most likely pick 60 fruits because it's very easy to divide them among the people. You could divide 4 fruits for every 15 people, 3 for 20, 5 for 12, 6 for 10, 2 for 30, etc., etc. Here is a puzzle in Pigpen code. The first word, I'll put little lines there just to tell you it's the first word. The first word will tell you what finger it is. For example, here's the index, middle, ring, which is the ring finger because you put rings on it, and pinky. The second one tells you which knuckle. For example, top, middle, and last or bottom. Now you could stop the video and try and figure out what the number is. Okay. Now let's decipher this one first. If we go back here, we see from what I remember, we had something that looks like this. So we had an R. Then we had something that looks like this. If I write the whole thing down for you. I think I could remember it. Now, what was the last one? Yeah, it looked like that. Here is an R. Here is an I. Here is an N. And here is a G. So it's the ring finger. Or about how some kids say it as the sister finger. So on this finger, if you still remember the Pigpen code, I'll try and remember that one now. What was it again? Alright, that's what we had for our Pigpen code. That's an L over here. There's the dot. Don't remember those dots. They're very, very important. Then we have A, S, and T. So it's the last one, or the last knuckle is 9. So as it said here, there are 4, and to spell 9 you need 4 letters. Next, from my memory, it's middle, because here is an M, here is an I, like we always use I, and these are 2 repeating Ds. I have a memory, memory like helper. To memorize these, you just put lines near them and then they look like Ds. So that's double D, that's an L. I kind of ignore that dot and then I just say it's L. And then E. E's in the box. Middle, and here is, as you all guessed it, top. So middle and top, which is 4. So that's 4. And it also takes 4 letters to spell the number 4. Now we'll look at rotation ciphers. Here I got 2 images, one of a rotation cipher, the other of an alphabet. But why are we looking at alphabets? I thought we were looking at... I'm getting a bit messed up. But why are we looking at alphabets? This is ciphers. Ciphers include alphabets and also numbers. So that's why we need the alphabet. And by the way, we use ciphers for a particular reason, to hide secret messages. And we don't write in numbers. We write in letters. Now, remember, as I said earlier, on the first slide, I talked about if I had the letter A and my key is 3, what will A with the key 3 be? It's D, because you count up 3 from A. Just ignore the A. Say that you're coming from the A, but you're not really going to count the A as 1. You're going to just count it as 0. So that's 1, 2, 3, and that's D. Oh gosh, I'm just getting a bit funked around with this app. Please wait a sec. Oh gosh, alright. I'm just going to move this. Alright, now it's all good. Sorry about that. Here you could have a try for yourself. Key is 9, message is this. Spaces don't mean anything. Oh jeez. And just erase that out. You use this alphabet chart to help you decode this message. And just a quick reminder that when you're decoding, you're not going forward. When you're encrypting or making it hidden, you go forwards. But you do the opposite when you go backwards. For example, if I start out with the letter D, I won't go on and say that the secret message is G. It's A's. You're supposed to go 3 back. 1, 2, 3. I'll give you a couple of minutes to do that. Okay. Now I will talk about something called the brute force attack. Or for this, it's brute force attack. I know, although its name sounds funny, it actually really doesn't mean that's bad. You could do the brute force attack, but not really to like a website to steal stuff. That's really brute. So what the brute force attack really does is it gets you the de-encrypted or the secret message in just 1 step. Well, I'm just lying, 26 steps. But it's pretty simple. What you do is, for example, we say it's R. We go to R and we test R for key 1, 2, 3, 4, 5, 6, 7, 8. What? 8 that's said. Now it's only there. Who knows what the secret message is? Or the key might be 9. What we do is go back to the beginning. So just counting up. Alright, now we reach 26. So if you just want to leave the message the same, it's just key is 26, just the same. Now you could figure out what this is. It's actually nonsense. Just practice that brute force attack. And you have, in real life, the hacker or the person who's trying to steal the information from a bank or university or anywhere else, they have to choose which one makes sense. So try and solve this one is actually nonsense. Well, just tell me if it's not nonsense. And you could do that in a minute. Great. Now we could play around with ciphers. Since we know all of our ciphers so well, it's now time to create some of our own. Here I got an example. A is a head, B is a head with a body but no arms, C is just the whole body but with no legs or feet. He's with feet, and it just keeps going. One shoe. Or you can do something simple like this. A for apple, B for bananas, C for cat, D for dog, E for egg, F for fish, G for grapes, H for house, I for ice, and J for jacket. I'll give you a few more minutes to make your own ciphers and maybe create a message and teach your parents or friends how to decode and work out or like in script your cipher. And thanks for watching. If you have any questions, please don't hesitate to put them in the comments below. And I hope you learned something new and enjoyed the video. Thanks for watching. And you can solve this last puzzle. I will go back to the Pigpen page. Here, stop the video, draw it, take a screenshot, or just quit the video and go to Safari and take a look. And now you can do the puzzle. Thanks for watching. Hope I'll see you soon. And bye.